Hi, in this video basically I will describe about Curtin-Hammett principle and its applications in diastereoselectivity selectivity in reactions. The Curtin-Hammett principle is applicable to a system in which different products are formed from two different intermediates, but at the same time these two intermediates should be in equilibrium with each other. So you may think what these intermediates could be. They can be either isomers, conformers, or intermediates. The other important thing that is need to be fulfilled within Curtin-Hammett principle is that the formation of product 1 and product 2 must be irreversible, and these two products should not be interconvertible. So the basic idea of the Curtin-Hammett principle is that the ratio of the products is determined by the relative heights of the highest energy barriers, which is leading to the different products. But here I have given a reaction scheme. So by looking at this, you may think maybe the stability of the intermediate also affect the ratio between product and product 2, but this is not quite right. So let me explain this by using a simple reaction coordinate diagram. So I have shown the same reaction with the help of reaction coordinate diagram. So you can see the intermediate 1 and intermediate 2, they are in equilibrium with each other. So you can see the energy barrier between two intermediate is much smaller than the energy barrier between two products. And when you carefully observe the reaction coordinate diagram, you can see the pathway leading to the product 2 is deriving from a relatively stable intermediate, which is intermediate 2, and the other way around, the pathway to the product 1 is deriving from a less stable intermediate, which is intermediate 1. Having said that, you may think that the product 2 is the major product because it is arising from a stable intermediate. So this is not right, because according to Curtin-Hammett principle, the stability of the intermediate is not important in diastereoselectivity. So it is only the energy barrier height which is important for the diastereoselectivity. So according to this reaction coordinate diagram, delta G1 and delta G2 is the major factor which is determining the diastereoselectivity. So you can see the delta G1 is less than delta G2. That means the pathway to the product 1 is having less energy barrier than the other. So the product 1 is the major product from this entire reaction. So the ratio of the concentrations of P1 and P2 can be given using an equation. So the ratio of the concentrations of P1 and P2 is equal to the equilibrium constant between two intermediates and the ratio between the rate constants of formation of product 1 and product 2. Let's look at the applications of Curtin-Hammett principle. So the Curtin-Hammett can be used to predict diastereoselectivity of a reaction. So here's an example of addition of hydride to a carbonyl compound. So we can have two products. So this is major product and this is minor product. So let me explain how you can determine the major product using Curtin-Hammett principle. So these are the most preferred two conformers of the starting material. So among them, this conformer is most favorable because of two reasons. So as you can see in this, the nucleophile approaches the carbonyl group from the side with the smallest group, that means the hydrogen. And the other thing is, the eclipse in between oxygen and methyl group is more favorable than in any of the other possibilities. So according to this conformer will lead to the major product, while the other conformer leads to the minor product. So here's the same addition reaction that I have shown in the previous slide. So I described it with the help of reaction coordinate diagram. So these are the two conformers that which act as intermediates. So when you carefully observe, you can see the conformer which is leading to the major product has slightly higher energy than the other intermediate. This is because of the eclipse in between the methyl group and oxygen. But as I mentioned earlier, the stability of the intermediate is not important in diastereoselectivity selectivity according to Curtin-Hammett principle. So it is only the energy barrier of the formations reactions. So you can see this conformer has smaller energy barrier than the other reaction pathway. So this will lead to the major product and the other will lead to the minor product. So this is the end of my demonstration for the Curtin-Hammett principle. So thank you very much.